ahead and give your talk.
Wonderful. Wonderful. Thank you so much, Dr. Moore. It's really an honor to be here. And this is a topic that, is very important and near and dear to my heart, just AI in general, but specifically when you talk about language and in the African context, it becomes something that is so critical for all of us. So I'm going to share my screen now. Can you see my screen?
Yes.
Okay, wonderful, wonderful. Thank you all for being here. I'm really delighted, by the audience that you all have, such an interdisciplinary mixed background. We had opportunity to share earlier, and there's people from actuarial science, from applied mathematics, there are optometrists in the room, data modelers, et cetera, health informatics. And so this is tailored to all of us, really. The title is, Large Language Models in Healthcare in Africa. I'm glad I was happy to hear about what the topic that your last speaker covered. That's very relevant, both the historical context of how we came to be here as well as where we are now. Large language models are the tip of the spear. They are the leading edge of where AI is as a field. And there's generally unanimous agreement that is the direction of everything. And I'll try to, I'll say a little bit about why that is. But that also underscores the importance of why this is so critical, because AI and LLMs in particular are poised to change all of healthcare, all of society, really. Thank you for having me. I have some financial disclosures. I have a couple of patents within the AI space, but I have no financial interest in the specific content of this presentation. We're going to start out with, because we're a mixed audience. A lot of us, know what AI is. Some of us more so than others. So I'm going to talk about what I see AI as being, right? And then I'm going to also say something about what I see language as being. And that's going to set the stage and contextualize basically everything else that I'm going to say. And then we'll look a little bit into how AI is developed, and this is going to be interesting, regardless of whether we're an expert data scientist or whether we're new to this and trying to understand how AI would impact healthcare in Africa or our daily lives or our jobs. And then I'm going to talk about how AI is changing healthcare and a little bit specifically about what we at Retina AI are doing. And then a little bit of a forecast as to what does the future hold, given where we are here today. Okay, so what is AI? So AI is really, in the broad sense, any algorithm that has learned, right? Learning means, you can start, it depicts change. The idea that you didn't know something, and then through an active process or inactive, whatever the case, but from going from not knowing to knowing is learning, right? So an algorithm that can go from, it doesn't know the answer, and then you do something to it, and then it knows the answer, that's learning. And it's happening from data. And once it has that knowledge, it can then perform certain tasks, right? It can answer questions, it can diagnose disease, whatever the case might be. So any such thing is AI, right? And that definition admits a lot of things, right? It admits, it allows you to call many different things AI. The fact of taking an algorithm that allows it to learn. For instance, it allows you to call any kind of classification system or even conditional or symbolic manipulator, something even your if-else function in your code somehow, and certainly more sophisticated things like, linear regression, things that you might otherwise not necessarily just look at and say, that's AI right there, right? If, for instance, if you have something that takes in the color of something, is it red or is it green? If it's green, I'm going to say the apple is unripe. If it's red, I'm going to say it's ripe. And it's just an if-else. It's two lines of code that this broad definition allows you to call that AI. But I think deep down inside, all of us would agree that, that's a stretch, right? That's probably not AI. it's learned something, you've kind of taught it something, you've programmed something into it, but is that really AI? And the more you, what's really going on here is that you programmed it in there. It's almost like hard coded. You already knew the answer. You just told it the answer. Um, but the more that your algorithm itself has to actually actively learn something through an iterative process in the way that a child would learn by being, or even an adult, right? You say repetition is the key to adult learning by being exposed to a lot of instances and scenario. The more you are doing that, the more like you're getting closer towards the idea of intelligence and the way that it's developed in the biological sense. The more you're going to be pointing towards one thing, and that thing is the neural network, so-called deep learning. And in the modern sense of AI, what you and I think of as AI, and I would go further and say what is AI, is something that is based on the neural network. Yeah. And all the other stuff, we're going to call it not AI. All right. So now in my talk, I had these big letters, large language models, right? So what exactly is language? And when we ask each other that, we have a sense of what language is, right? You and I have a sense of that language is what I'm doing right now. I'm speaking and specifically English, right? But I could be speaking Twi or Yoruba, or Hausa Igbo or Swahili, African language. Um, that's natural language, and that certainly is language. But what we're seeing with the evolution of, and we're learning about what language is, we're learning more and more from, this process of how AI is evolving, and it's evolving so fast now with a lot of the attention of society and the resources to boot. We're starting to realize that, really language is beyond just natural language. But things such as images, right? A picture. We've always had the concept of a visual story, right? That you can look at pictures and you can put things together. Silent movies, for instance, clearly told a story without a single word or text. So when we, in hindsight, yes, language has never been just about what we write and say. It's been deeper than that, right? It's been more general than that. And now we're also sort of having this epiphany moment that we all always kind of knew. It was sort of hidden in plain sight that even code, for instance, are called programming languages. So we've always known this, So that entire GitHub repository that now becomes a data source for training machine learning algorithms that can now do Copilot or actually just construct code from scratch. Andrej Karpathy, tweeted something recently that, the latest the latest programming language is, guess what, English, which, there's a lot of truth to that with some of the novel technologies that have been deployed to the public now via, say, OpenAI, for instance, can generate a lot of things from natural language because we're now able to do these mappings more specifically. And clearly, you can see that we're on the on-ramp and that the whole world is changing and entire industries are changing. And we're at such an inflection point in our civilization that it is so critical to understand all of the moving parts to the extent that we can and influence that process to the extent that we can to ensure that that Africa doesn't get left behind with all this development. So not just code, but also DNA sequences. It gets down to the biology, the very at the very molecular level, right? At the level of amino acids for protein sequences or nucleotide sequences in the case of, DNA and RNA. That is a language, clearly, right? And we've always called it that, and we know that it is that. But what's so new about today is that we actually now have this enormously powerful and transformative machinery that can speak that language and translate that language. And then even physical phenomena. The fact that when I hold up an apple and let go, it drops down, right? It's a language. It's an understood language. It's a physical language. So all these things are now in play, ladies and gentlemen. It's quite a time that we live in. So that's what language is. So now that we now see how broad this is, my title, large language models, it now seems even more striking than it would have otherwise. So I have here just a number of examples from OpenAI on an algorithm based on an algorithm, DALI, which some people in the audience may be familiar with, and some are not. And it's basically a text to image translator. So you could use the AI was used on a lot of data that existed on the internet, right? Both text as well as images. And now that I took so much time on that slide talking about what languages, there's a reason why I did that. The reason why I did that is because that slide tells you where the research is going to go. It tells you what the future is going to be looking like, and it brings you into that process of development where it breaks down the silos of that's NLP, this is computer vision. Those walls are broken down when we broaden the definition of language, and we start to see that the way we build AI systems for language and for image and so on and so forth are going to start to have a common language. And the ability to speak a common language is a bridge to development. That is the first step, right? So for those of us who read the scripture, you might remember the story of the Tower of Babel, right? Where the humans said they were going to build a tower that was going to get all the way up to God, and they would be greater than God. And that was a bad thing to do, to try to do. And what God did was, so you guys, you created creatures, so to speak, are now trying to aspire to, in a way that is rebellious, to build these great towers. And God just had to do one thing. What was that? Put it in the chat. Let me see if I got it here. Okay. Resume share. Anyway, I don't think I did that right, but I'm sure somebody has said the answer. And that is basically disperse these people and make them not be able to speak the same language. Okay. And that was enough. That was enough to completely stall that progress completely. So by analogy, right, you can see if you look at the history of AI, and very few people know the actual history of AI because it's been mistold and oh yeah, here we are. I can now see the chat. Let me see. Made them speak different languages. Jacob Ojomu says, yeah, absolutely. And Obuda Ungu as well. He changed the languages that none understood the other. And Daniel Saprong says God confused their languages. Absolutely. And that was it. That's enough. So if you want to make progress, and if you want to make a great amount of progress, and you want to do that, do it very quickly, you should focus on. I'm clicking different buttons here, and I hope you guys can still see my screen. If you can't, please do let me know at any point, because I'm sort of, yeah, I'm gonna keep going, because I think I'm okay. But if I'm not, you guys should tell me, okay. So I'm trying to get this out of the way. There we go. Okay, good. So yes, so getting them to speak different languages was sufficient. And when you look at the history of AI, you'll see that there are critical times at which the silos of language, and I say this more generally, were broken down. And immediately afterwards, what we saw was an enormous acceleration of progress. Okay, so one such instance was in about 2011, 2012, right? In 2010, Fei Li launched the ImageNet, or actually 2009 is when it was initially presented. It had been built up for about 3 years prior to that. And then the ILSVRC, which is the ImageNet Large-Scale Visual Recognition Challenge. And at the time, though deep learning had been around for easily a good 30 years preceding that, since like the mid-1960s, right? Ivanchenko, the first deep learning models, and convolutional neural networks in particular had been around since 1979, Kunihiko Fukushima. The confluence of things such as compute power with your NVIDIA GPU processors, and all of the ingredients that we currently use today, such as backpropagation and stochastic gradient descent, et cetera, had all been in place. And in 2011, these computer vision models started to win competition, right? And specifically DANNet. DANNet from Jürgen Schmidhuber's group won about 4 competitions in a row. And a year after that, AlexNet from Krzyzewski, Soskeva, and Hinton, won the ILSVRC. These things drew so much attention to this idea of deep learning, which was not new, right? And to this idea of computer vision and convolutional neural networks, which was not new. But just the fact, the performance and the superhuman performance that was seen is often attributed as launching the deep learning revolution, right? So after that, what happened? Year after year after year, breakthrough discoveries, like the year after that, 2013, variation autoencoders. The year after that, GANs, generative adversarial networks, which, by the way, were not new, had been around for 30 years also, but were sort of rediscovered. The year after that, diffusion models. Now, this DALL-E is a diffusion model. Right? Has anyone heard of Sora? I don't think I'm going to click because I think that'll be a divergence. But anyway, Sora is was released last week. Yeah, I think exactly a week ago today. And yes, one person has said something. I am going to click on it because I can't help it. Yes, absolutely. Good. So Jacob has heard that. And yeah, absolutely. So Sora is a text to video. You basically type whatever you want to type, and it will generate a 1 minute long video that's on OpenAI's website. You can check it out and test it yourself. And that's a diffusion model. DALL-E is a diffusion model. So these came out in 2015. 2016, what happened? Big landmark scientific discovery. AlphaGo Zero beat the world's best Go player. The year after that, AlphaZero beat AlphaGo. So you started to see different fields like physics, thermodynamics, coupled with deep learning. That's where you got the diffusion model. The year prior, you saw Bayesian inference, right, coming together with deep learning. That was the variation autoencoder, right? And then 2016, we saw reinforcement learning coming together with deep learning, right? Coming together with heuristic methods like Markov chain search, MCTS searches. Boom, you've got these landmark discoveries. And then 1 year after that, we got the transformer, which was bringing together basically the classic problems from NLP, right? Where you had this issue with long-term dependencies. Bam, you add the deep learning to it, add that knowledge to it. Boom, things moved along. What was the key explosion that happened after the deep learning revolution? Was really these different fields started to be able to speak the same language, right? And we're going to see the same thing happening now that we have these large LLMs, and we're now starting to broaden the definition of language. Now we realize, oh my gosh, any kind of data really is language. Guys, ladies and gentlemen, strap on your seatbelts and get ready, because in the next 10 years, we're talking about exponential growth. And that's because LLMs, and then the idea that almost any kind of data or even physical phenomena is language. When you put those things together, what we're going to see is going to be quite mind-blowing. Here's a few examples. Somebody just typed in, astronaut floating in space, and you type it in. It never existed. This image never existed. You created it in your mind. You type it into the prompt, and boom, astronaut floating on a cloud in space, and there it is. That's quite remarkable. Initially, you're looking at this as perhaps entertainment value or aesthetic art, but very quick. But I assure you, we're going to start to see very serious applications within healthcare, within the fields of neurobiology, neurology, neuroscience, neurosurgery, and psychiatry. And some of these applications are going to be and ophthalmology, vision, and so on. There's going to be so many applications that would come out of this that are very serious, that would be life-changing for a lot of people. Okay. Here's another example. Somebody just typed something about, a camera floating in, with algae and so on. And they dreamed this up. And if you read the prompt, you'll see that, wow, this is exactly but this is not an image that would ever have existed prior to this person typing in a photo showcasing a camera crafted from corals and jellyfish immersed in the vast blue marine depths. The camera's outer surface is festooned with corals and radiant gold metallic accents, blah, blah, blah. Boom, there it is. And similarly, here's another one with enormous excruciating detail that the AI was able to create. And the why it can create it, again, I'm going to repeat, is that, there have been images on the internet, right? And these things were trained with, the NLPs are traditionally trained with text, right? With corpuses such as Wikipedia, right? English Wikipedia, for instance, which is a large body, or the Toronto Book Corpus, and web crawl that can just go on the internet and pull things from different websites. And then you also happen to have images, right? And now we're starting to see smart ways that are mathematically very simple. We have a few mathematicians in the room, and a couple of web programmers. And when you put an image online, there's an alt text that's embedded in it. And so now there's automated ways which don't require the human intervention in the loop, at least for pre-training, which is the initial pass of being able to use vast amounts of data and compute and couple that with vast amounts of compute. Now you have things like OpenAI, like a CLIP, like a contrastive language image pre-training algorithms that are learning a common language and are automatically learning to tie in what we traditionally thought of as NLP with things that we traditionally thought of as computer vision. And we have certain links that are already in the wild, in the native state, that can be automatically pulled in and used for pre-training. And then you can then on top of that finesse. And so that strategy, right, is critical. And that strategy is going to dominate, I would say, and would yield enormous mind-blowing applications over the next 10, 20 years that we're looking at, which is to not go veer off too much mathematical, but that's really, we're looking at a melding, an amalgamation of modalities in a latent space. And what that allows you to do is it allows, because your AI has already learned these connections and associations implicitly, it allows you to do what, some people might call zero-shot inference, right? To create things that never before existed because you've learned a latent space in which they exist. And so you can sort of call it out. And that's what we're looking at. And so these are other examples of things that people just thought up and typed up and it came to life. Here's one that I made, and this tells you about the African context. So this is a series of images that I created from the prompts in November 2022 when ChatGPT first launched, when it got all big and it's all so excited. And, I typed in some Nigerian things, and I know you guys, I'm sure everybody in the room is very well aware that Nigerian jollof is way better than Ghanaian jollof, right? So that was sort of the starting point for these prompts. And I created a number of things. I'm kidding, right? I don't, actually, I'm not. Nigerian jollof is better, and you guys know it, okay? So one of the things, these were just fusions, and this idea of once you've learned a joint latent space, you can call things out, mixtures, like mixing of the eigenstates, right? To use a mathematical or a physics term. These are foods that don't go together. Like here, popcorn jollof. We know what popcorn is. We know what jollof is. But nobody knows what popcorn jollof is. Well, here it is. And ChatGPT can tell you, and this is, again, this idea of melding, or rather, this was a DALI, melding these modalities together, the idea of vision and text and NLP. And there it is, and it looks just like that. In Nigeria, we have something called amala. And I asked for amala cookies. Amala is like, it's like the fufu type of stuff now. It's like swallow. It's the thing that's on the side. So the amala goes with something called gbege. Okay, we just asked it for amala cookies, and guess what it did? it actually served the bakery by itself of its own volition on the side. And it shaped the amala like cookies in the one instance. In the other instance, it made cookie dough into amala. And so you see all these combinations, suya, strawberry suya, and so on and so forth, and then eba boga. And these are all things that Henry says Ghanaian jollof is the best worldwide. No challenge from anywhere. Well, I beg to differ, okay, Henry. Nigerian jollof is number one. So amala boga was another one here, and you can see just the creativity that comes to life. So yes, what this tells you, this slide tells you that there are opportunities within what's already existing for us to leverage some of the potential as we go forward. I only have 15 minutes till the hour, to the top of the hour. So I'm going to speed things up a bit. Thank you. I've got some support in the room. Jacob Ujumu says Nigerian jollof is always number one. Thank you. Thank you. Okay, so I'm glad. So there is opportunity, but there's also enormous amount of challenge, right? Because African language and the African experience is greatly under-documented, under-resourced, right? There's so many things that, I remember, because I grew up in Nigeria, came to the US when I was 17. And there's so many things I remember from my childhood, experiences that, you can talk to other people about and with, but it's not anywhere on the internet, right? I'm American and Nigerian, but there's almost no component of the American experience, for instance, that you can't find documented very, very carefully on the internet. So you can imagine that as you start to use data to train models and build solutions for people's problems, you can imagine that this can result in a widening of the gap between the haves and the have-nots. And so this becomes a really critical issue. Okay, so yes, and these are just some other examples of how I checked out how ChatGPT would respond to certain questions, and it was quite impressive. One of the questions is, I asked it about a certain disease that happens in the retina. I treat a lot of this, more in the US. I'm sure this particular condition is probably less in Africa. But I asked it, how does one treat wet macular degeneration? And it gave me an answer that was not unreasonable. And then my next question for ChatGPT was, what types of anti-VEGF medications are available in the US? And it answers reasonably well. It left one out, and so I say, how about Vabysmo? And it says, I don't know what that is. And maybe it has another name. And I told it the name. And it gives me an answer that is not unreasonable. It was like 2 years outdated. It said something about they're doing clinical trials right now. However, it was already approved. Clinical trials were done. The results were out and all of that. But I was, you're almost interacting with a human who just needs to sort of update their knowledge, right? And one of the important things about the development of AI is when you look to apply AI to a specific industry, in our case, or a specific domain of life, in our case, healthcare, it's the same AI, really, right? Because the math is the same. Okay, data is data. What you call it and what you're using it for is the only thing that's different. Here's an example. The classic example of training classification models is cat versus dog, and you train an AI to do that, right? That was sort of what triggered all this AI revolution in 2011 with DanNet. And you can do that, we know how to do that. We know because a cat is different from a dog. It's a classification problem, okay? No problem. Well, what if you were trying to tell if somebody has a disease or not a disease? It's the same kind of problem. It's the same math, it's the same code, it's the same thing. In that specific context, you didn't have to specifically make sure you're building it to work for that specific thing and it's safe and effective. So here is an example of like something on somebody's skin. And this is a classification problem because I could ask the AI, but you have to train it. You can train the AI to be able to tell you what this is. Same math, same type of thing. Is this a melanoma or a squamous cell carcinoma or a basal cell carcinoma, or is it not cancer at all, right? Anybody want to venture that in the chat? Take a stab at this. What do you guys think this is? I'm going to give a minute, or I'm going to give 30 seconds. Da-na-na-na. not cancer. Salome, Salome, welcome. Thanks for joining us. Thanks for joining us from the UK. Not cancer. Well, let's see. I'm glad. Thank you for trying. Thank you for being brave. Um, and AI would not be sure either. That's why it'll typically give us a probability. In this particular case, it turned out to be squamous cell carcinoma, right? And again, this is just a classification problem. You could have another problem. In this case, anybody want to take a stab at this? So in this case, I want somebody to try this one. Take a shot. Let's see how much time we have. Melanoma, fantastic. Thank you. Dr. Yaboa tells us that it's melanoma, and that is correct. And so again, the take-home point here is that when you know how to solve these problems, you can extend them. And so that's why it becomes important to spend the time making sure that we've got the math right and we got the code right. And you can then extend it to a lot of different things because we contextualize these problems and solve them for general purpose, and then we can then fit them to healthcare. So here's an example of a person with a lung nodule, right? And so there's something called object detection, which is different from classification in AI. And this is basically just an object detection problem. Do they have a nodule or not? Is there cancer in the chest X-ray or not? And it can tell you whether there is or there's not. And then and once you have all of that, so that's why it becomes important to look at how the AI is built. At the very beginning, I emphasize that AI today really is about learning, is about end-to-end training from data, and AI has revealed itself to be that, so to speak, right? And so different things like logical programming and so on, those are not AI, because they're not really like learning systems per se. Neural networks are AI. So that's the core of what the AI is really a neural network. Okay. And I would love to talk about the history of, how this all came to be, because it's quite a fascinating history. And it's taken quite a while to develop to this point. It's taken a good 3/4 of a century from all the critical parts and components coming together to be here at for such a time as this. And the basic idea is that you can have images and whether disease or not disease. Take a bunch of data and then you get your neural network to learn by when it gives you the right answer, you reward it just in the same way that one would train, say, a dog, Pavlovian. When it gives you the wrong answer, you say bad network, and good network, bad network. And you just do that for hundreds and hundreds of times, not hundreds, thousands, millions, billions, depending on what you're training and the size of it. And eventually it gets the answer right. And then you have a trained network, right? And regardless of what you're trying to train, what disease, you just have to have the appropriate label in. And now that we're now seeing this idea of with things like, CLIP or using things off the internet, contrastive learning, that's melding, subfields. You can even do some of that labeling in a so-called unsupervised way. Unsupervised is a misnomer. There's no such thing. When you're doing AI, you have supervision because if you have a loss function, you have supervision. But that's interesting, right? And this is the way it works. This is sort of a diagram that shows you how at each step you basically update the weights, update these connections. That's the knowledge. The weights, the learnable knowledge is called weights. And you use something called back propagation, right? By Seppo in 1970, which really is running the chain rule in reverse. Chain rule dates further back to Leibniz in 1676, right? So you see that a lot of things have gone into getting us to where we are. And then, but now that we know what these networks are, right? There's been a lot of talk about LLMs, right? You've heard almost every other week since 2018, we've heard things like BERT, PaLM, Llama, blah, 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 blah. It just never ends, right? And there's clearly this arms race between the big tech giants and everybody else, between each other, because it takes a lot of resources to do this pre-training things. And really, the transformer is really just a bunch of neural networks. All these are neural networks, right? There's the encoder, and then there's the decoder. And we can talk about the details, but that's not what this talk is about. But basically, you just understand that you can essentially train an AI on a lot of data, like in the classical case, let's say text data, like Wikipedia, and you can set up different tasks for it to do. Like you can say, I'm gonna make this AI do a fill in the blank test, where I'm gonna give it a set of words, and I'm gonna just that last word, I'm gonna hide it, and I'm gonna make the AI do that thing. If it gets it wrong, bad network. Gets it right, good, and you just keep doing that until it learns how to fill in the right word precisely. You know what the right word is because you have English Wikipedia and you use the code to just remove that last word in something called autoregressive learning. That's a classic example. And you do that enough times, it turns out that by the time your network is good enough to get the last word right, it has become almost an embryo of an artificial general intelligence. It has become a ChatGPT that's almost talking to you by just that simple task. Because for it to get that last word right, it has had to learn so many things, about synonyms, about antonyms, homonyms, about context. Context is a key term here. And for it to learn all that context, it has become super smart. And so this brings us to where, when you look in the African context, you're like, wait, you realize, wait, these transformers, BERT, etc., they were trained on English Wikipedia. Of course, language, regardless of which language it is, whether it's Swahili or English, has a lot of things, in common. But there's going to be some key differences, right? And so the availability of data for African languages then becomes such a critical problem when you then see the connection between where this technology is now and its significance in the sense of within the scope of human civilization and history. All right. This slide is for the math majors, but we can come back to this, during question and answer. If you want to look a little more into the transformer architecture, you can also follow me on LinkedIn because I post these things periodically on there. So data, right? That's a lot of what I've been talking about is in the modern context of what artificial intelligence is, it's learning from data. And that basically means neural networks. That's the definition. AI has revealed itself to be that over the years. And with African languages, under-resourced, underdocumented, right? And that's a problem because why is it a problem? Because it's the data that you use to train the AI. Now, this AI, now that we know that language is not just natural language, but basically everything, including physical forces in nature, like gravity, something so basic, and like your DNA sequence and so on. Not having the data simply means that the systems that are going to be built that revolutionize all industries, it basically means being left behind, right? So that's why I now put it in red with exclamation mark, is that effort does need to be made and can be made, and progress can happen and is happening. I use my example of jollof rice and amala and so on. So there is stuff on the internet and there's work that needs to be done, but that work does need to be done. A lot of work is already being done. I'm very grateful for Dr. Stephen Moore inviting me here to speak. He's the convener of Ghana NLP, for example, has been chugging away at this problem, as well as the Masakani project is one that's led by Vusi Variere in South Africa, but it's an Africa-wide project involving, I believe, over 30 or 40 African languages, which is an enormous effort. Afro LLM by DSN, DSN AI. Dr. Moore mentioned in the introduction that I'm on the advisory board of Data Science Nigeria, so that's a significant effort. And then there's also a few other companies that are interested in this, such as Infront Health, Tobiolatunji, for instance. So there's a lot of work that's being done. And so that's on a note of encouragement that there's, collaboration, speaking common language, working together, etc. This is not like a hopeless thing. It's just a flag that one does need to be careful, be aware, and make sure that effort is supported so that work can happen, because it's work that absolutely does need to happen. It's the top of the hour. So I have 1 minute to talk about the retina, which I'm going to just sort of fly through it. I've kind of already sort of given you a flavor of what we're doing. What happened.
You can have 15 minutes.
15 minutes. Oh, great. Okay, wonderful. Thank you. Very generous. So in healthcare, one organizing principle is so-called value-based care to improve healthcare. And the idea is that to set your objectives as, I want to attain higher quality care, better outcomes. I want people to do better than they're currently doing. That's number one. Number two, I want to do that by spending less, right? And number three, I also want to do it in not only spending less, but the patient comes out and says, that was a much better experience than I had when you were spending more, it was costing more, and the quality was bad. So that's amazing. Like what's the catch, right? So basically, there's enormous inefficiencies in the system that need to be squeezed out for this to be attained, right? So in machine learning speak, we want to get to a more optimal place. And you can think of AI as, you can think of healthcare as involving two things: clinical correlation in the context of AI, which is like, I want to diagnose a disease by reading a chest X-ray. That's an example of computer vision. Or maybe there's blood work, a blood test, and some kind of chemical. We have chemical engineers in the room. We have information management people in the room. That's great. And you want to run a blood test and see what's your blood sugar. That's not imaging, but that's also a clinical correlation to tell you something about the state of health. So that's one organizing division. Another one, and I came up with this myself, so feel free to make suggestions. The other one is information management, and clearly I've taken great pains to establish that language is basically all of information is language. And so in the context of healthcare, the electronic medical record is a critical instrument for collecting information about a patient and the state of their health. And then there's also information that is not necessarily in a medical record, right? And one of the places where this value-based care paradigm clearly becomes important is in screening, right? If you want to, so value-based care, I said, you want to spend less money and get more good outcome out of it. Screening is a great way, as opposed to waiting for somebody to develop breast cancer and then they have to do mastectomies, chemotherapy, radiation therapy, et cetera, and then possibly even have it pass away after long period of enormous burden financially and emotionally or psychologically on them and their family, et cetera. Instead, just screen every woman at a certain age and find the disease early and take care of it early, and everybody's happy. That's an example where AI will shine very brightly, is in screening. There's in the US, for instance, there's also another utility for this, early notification of stroke. There's a company called Viz.ai that does, when a person is having symptoms of a stroke, it can be due to occlusion of the large vessel occlusion. And if you detect this within 3.5 hours of its onset, when it starts, there's a type of medicine you can actually inject into the veins to the blood vessels to clear things up. It's called TPA, tissue plasminogen activator, and it has to be done by a neurointerventional radiologist in a suite. There's all the setup and everything. So time is brain is the term that's used. You have 3.5 hours from when the thing starts to get them. They were in their house when it happened. You got to get them in the ambulance, get them to the hospital, do an X-ray, etc. Get them into the suite, and if you find out that you need to do this treatment, so AI is now being used to fasten the process by detecting if they do have an obstruction and are a candidate for the procedure. Then you just set up the room, get the interventional neuroradiologist in the room, and then you move the patient there and skip the time wasted in having a radiologist have to confirm. And that's an autonomous process. Our company, Retina AI, is focusing on diabetes. This is a big problem. Diabetes affects 500 million people around the world. And it's an increasing problem in Africa as well. And, everybody that has diabetes has to have an eye exam. I'm glad there are several optometrists in attendance in this talk. And so we all know that you have to have an annual eye exam for diabetic patients. Otherwise, the disease just progresses over time, and they can go blind, right? But if it's detected early, we can treat with injections and laser, And so, but there's really in the US is one of the most resourced countries in the world, right? And in the US, a study in 2019 showed that 50% of people who have insurance who are diabetic did not get a single eye exam in 5 years. It's shocking, right? So diabetes goes from, this is an example here of a person who's has no disease, no diabetic disease in their eye, but has that, and then, this is an example of a person with moderate diabetic retinopathy, a few dark blood hemorrhages here and there. And then here there's a large, these blood vessels shouldn't be there. These are bad blood vessels. They're called neovascularization of the disc. That can break and can bleed and can cause a vitreous hemorrhage, like in this case, ultimately leading to fibrovascular scar and traction, retinal detachment and blindness, which is the end stage of the disease. So you don't want all that to happen. You want to do this yearly screen and be able to catch something early and treat. That's the whole idea. This is retinal detachment. And so that's what our company has focused on. We've built an autonomous AI system called the Retina AI Galaxy, and we conducted the largest clinical trial ever done in the United States of America for an autonomous AI system. We got great results. We concluded our study last year, and we're now submitted that to the FDA for review. This is an autonomous system that no doctor in the loop that can help prevent blindness in effect. And this is sort of the shape of the problem, these types of problems that AI would play a role in for screening, things that are needed by the general population, and that really there are not enough, humans, that is for whatever reason, not just not enough humans, but obstacles, including cost, including logistics, et cetera, just not happening and people going blind. And so that's where the AI, is playing a role in that case. So that's the idea, is that we have a camera in primary care doctors' offices, because the patients do go to their primary care doctor. 98% of those patients who got no eye exam in 5 years all went to their doctor every year. And so you put the camera there, and our device is a cloud-based device. So you get your diagnosis within 10 seconds, and it tells you whether you have to go see an eye doctor or whether you get to go home, right? And so here's the interface, and you get a diagnosis, I say, within about 10 seconds. And this is the value-based care paradigm. The whole idea is we want patients to do better. We want to save on cost to society and to the patient, and we want better outcomes. And there are multiple opportunities for that. Clearly, electronic medical records is a language. It's a source of information, is the primary repository for that. And that's an area that should, and I'm almost certain will, but probably not fast enough, be revolutionized by language models. What's in the future? I've already sort of spent most of the talk talking about what's in the future. What's in the future is really us understanding and working towards this broader understanding of what language is. That language is data. Language is all types of information, whether it's pixels as in an image, or whether it's natural language, spoken speech, etc., or even the physical laws of nature. They're all language, and we can then learn the connections between these things. And what that's going to do is it's going to bring us closer and closer towards, within specific scopes, approximating at least the resemblance of an artificial general intelligence, which within the context of AI is going to be of healthcare is going to be very critical, very important. And building of these systems require are specific. And so Africa and African language and Africans need to be a part of that. This is some general generative work that I've done earlier, but I've already covered this in this talk. This is NL reinforcement learning. We've seen how these has revolutionized, and it's been applied to various types of problems. Again, we're going to see a lot of interdisciplinarity at this point, because the silos have been broken down. The silos of language in the AI mathematical computational sense have been redefined. And so things such as we've seen now that you can just enter a prompt and get a chair shaped as a strawberry, and it just happens, right? It looks like magic, but what it really is a melding and this is for the math majors, because I know this talk is being hosted by the math department. So I wanted to make sure that at least during the Q&A, if anybody has any specific questions, there's an appendix slide for you. But the take-home point here is that the multimodality is the key thing that we're looking at. And this is, I believe, my final slide, which is now about 2 years old. And there's the medical knowledge assessment test in the US to become a doctor. While you're in medical school, towards the end, and in the middle and towards the end, you take a test, a standardized test, to test your medical knowledge. 2 years ago, an AI, a large language model, right, scored 85% on that test. So you can be sure that in the coming years, within the next probably 24 months, you can push this to hit close to 100% on a test like that. That has huge implications, right? Clearly, the AI is not a doctor and can't be a doctor, but the way what we think of as education and what the objectives are of educating a physician clearly have to be rethought and perhaps completely overhauled. And that's it. We really could have continued this for another couple of hours, but I would like to hear if there are any questions, and we can go from there. Again, I'm a physician, computer scientist, and a practicing doctor, and I've had the privilege and the blessing of being able to bridge those fields across. And that's another opportunity I believe that exists, is for rethinking education. What are the goals of education, and how can we think about changing those things? So while we're building the future and thinking about Africans, the well-being of Africans, also taking some time to think about how can we redesign educational systems to make sure that everybody can reach their full potential would be important. And that's it for now. So I'll turn it over to you all for a discussion.
All right, thank you very much, Doc. This has been very, very exciting and insightful as well. So if you are online and you want to ask a question,
Yeah.
So someone is asking about the dangers of LLM in the future.
Right, certainly. Isaac, your question is, we've spoken at length about the promise of LLMs. What about the dangers? Do you foresee whether any dangers in the near or far or distant future? That's a great question. Absolutely. It's a powerful technology, right? That's the starting point. And like with any technology, can be used for good or for evil, and it's important to be clear on that, right? That this is a powerful, revolutionary technology. I've talked about a potential side effect of even attempting to use it for good could be widening of the gap between the haves and the have-nots, right? Further increase in disparities in healthcare, access to care, people's well-beings, and that particular attention needs to be paid to that to make sure that that doesn't happen. So even good intentions even can have negative, detrimental side effects on this.